How's it going, everyone? Welcome. Eulia Gonzalez here again, looking at the front-end system design. So, well, because in today's video we're gonna focus on how to build a Redis servers, which is something interesting in terms of gain some of the knowledge that's required. That even though that is something that is for backing applications, uh, is part of the knowledge that we need to know as we design this uh, front-end system applications, right? So this course, which is taught by Yves Ray, it gives us what are the responsibility that we need to take care and understand the fundamentals of each one of those fields as a way to now provide your service to companies when it comes to build now complex and large scale applications. So understanding these fundamentals for each one of those area of responsibility in terms of data management. First is API communications. How are you going to communicate with the API? What are the protocols that we're going to use? And as well as the architecture. Are we going to use GraphQL or REST, HTTP 1 or WebSockets or HTTP 2 or anything related to the TCP or UDP, for example, Quick or HTTP 3, right? And the data management, how we're going to store and manage our data here. So what are the principles that we need to take in considerations for application state designs, okay? So the TLDR is that whatever data that you want to store here, think of the scalability. How many data that you want to store in the client side first, and second, then start to define is the structure of your data. And here is when we need to take a look at this another course that is the this is the data algorithm. Let me see if I put it right here. Is it last? How did I write that? I really have this already recorded here. Jesus. What is this one? Okay, practical. There you go. Okay, is this one? So practical algorithm code, which is also, which is now is part of the front end master series from the Prime Gene, a software engineer that has previously that is currently working at Netflix. Okay, and that the idea and the goal of this is to have a conceptual and practical use common algorithm in data structures, right? So what are the most common data structure and how can we use this data structure to solve some specific problems? And here we have now hash, and here we have is a hash map, so array list, list, tree, heaps, graph, maps, and algorithm for searching and sorting, right? Pretty basic understanding here, and we also now take a look at the resource here, which come from the books, right? A more friendly approach of this, a common sense of data structure here, where this is something that we might like to take a look at this to understand now this. Okay. So who is this book for? If you're a computer science student, if you're a beginner developer, you're a self-taught developer who has never studied formal computer science, my case, or developer who did but forgot everything and wants to leverage the power of data structure and algorithm to write more scalable and elegant code. Whoever you may be, I tried to write this book so it can be accessible and enjoyable. This is more like a friendly approach to this. But in any case, Is there a video here?
Hello, I'm Jay Wengrow, author of A Common Sense Guide to Data Structures and Algorithms. Material and is to give the algorithm called insertions in sorted order.
Okay. Okay. So again, this is something that we like to actually visit later on this course as a way to refresh and now have a more to be as a sniper, to act like a sniper here. It's like, hey, you already have all of this stuff. You have your target, and then you just pull the trigger, right? This is a hash map. This is a linked list. A binary tree. So, and the other area of responsibility is, all right, now how we're gonna handle is the most common and sometimes complex user interactions, all right? Such as, for example, if we want to provide some analytics to how long this user is been on the page, or we want to show now component as the user scroll, all right? Virtualizations or adding lazy components as it is. All of this can be achieved with the interception observer, or if you want to now identify is or when your building is drawing tools or text-rich editors, you will like to use, or most of the time you use, is the mutation observer, or if you want to know or you want to build is responsive designs, drawing tools or charting or drawing charts or charting apps, right? You want to use is the resize observer API, and all of this come from this particular pattern, which is the observer, and how the observer in JavaScript has been a very powerful approach to actually is write concurring application, handle this task that overlaps over time. In any case, and also is well, how can we now is then manage our assets? So there's 4 areas here that, for the sake of the example here, is data communication, state management, user interactions management, as well as the asset management. We went through over describing is first how the browser works, how now the browser treats HTML elements, and how they participate into something called the formatting context. That this formatting context, well, is something that has close relationship with stacking context, and how we're using the stacking context as a way to now, by using CSS class, tell the browser, hey, I want you to use is GPU instead of CPU. And how can we now is prevent that the browser actually needs to re-render elements, or in this case to reflow this, by understanding is that how the browser render HTML, CSS, and JavaScript on pixel on the screen by looking at the critical rendering path, okay, which is the way how we transform all of these streams of data into DOM CSS object model, and then merge that to the render tree, that by the time that it has this information or this data structure, it say, okay, now I need to know how this element is going to be displayed on the page. I need to calculate its position as well as its dimension. This is now the reflow phase, right? As we look at this part of this, the reflow phase, and how this particular phase is being triggered usually by JavaScript to actually change is the CSS behind the scenes. And when you change, for example, is now position or the geometry of an element, you are triggering is this reflow phase or this layout phase here. So it means that instead of us having to trigger that, CSS now provides some convenience method to say, or convenience property to say, hey, let's now pass this computation here, okay, to someone who can do that much more better, someone who can deal with this, someone who knows what it's doing, the GPU. So by using this transform, for example, it actually is telling or is behind the scene is communicating to that. Again, there's some other CSS property that you can go with that it won't trigger is the layout phase like this. It just only now trigger is the paint, and the paint phase is to say, hey, now the browser has all the information that it needs, and it's going to pass now to the and you go now to transform this into bitmap, right? This digital representation of a digital image, where you have now this two-dimensional array, where each one of those elements, or in other words, is a two-dimensional array made of pixels, where each one of those pixels represents the intensity of a color of a grayscale. By using is the RGB or CYMK, depends on the representation here, but usually it's the RGB, because CMYK is for print media. Exactly. So this is a color model for print media, and then you have the RGB, RBG, where it stands for what? Really? Color. Okay. The RGB color model, right? Which is most of the time used on the graphic interfaces, right? So this is just to recap what now the GPU is all about here, to actually understand what is this, which is the architecture of this, and now that it has now this particular video processing unit, because it can be image or video, and it also have the power management unit. It's going to put all of this data that come from the bus into the closed memory, okay, into this closed storage, similar like your Pocket. So now it can actually perform what it needs to do, and that is, hey, I want you to transform all of this series of zeros and ones, all of this set of instruction in zeros and ones, into now pixels that can be transmitted with the display interface, right? So for example, like this, and this display interface, it can be VGA, HDMI, DVI, all of those display interface in the market. So this is huge to understand this, because then we're going to jump to what is relevant for us, right? And that is so building this Redis service. So just to briefly describe how do we get here, okay? We went through also is to know the DOM API and understand what is the DOM API, what it represents, what is the structure of this DOM API, and that is the class structure, where you have now the node, which is the entry point of all of this, the node. And from there you can extend. This is the abstract class, as they call. But this is where the origin of this, right? So everything starts with a node. As you can imagine, this comes from a tree data structure, okay? But it all starts from the DOM. That you can now extend some specific functionality out of that, and that is the text node, or the element, and from the element you can also extend that to have more functionality attached to that, such as the HTML, the SVG, MathML, and any other XML extendable or XML syntax or elements here, as well as the DOM document, right? And what are the now elements that we can have access to the DOM, all right? And some of the operations that we can act upon this data structure. So for example, get element by ID, get class name, get element by class name or tag name. What is the sort of difference between this and this query selector and the query selector all? The get element by tag name and class names actually now have access to the live collections, all right? So this is when, again, you can consider to use this, especially if you are going to, if you're sure that you're not going to iterate through these elements over and over or too much time, okay? And one of the benefits of the query selector is that now it provides us a copy of that. So we can now work on that. And unlike the document element and document get element by ID, is that, hey, you know what? This element is, we get that element fast, quickly. And what are the best practice to actually use this query notation, right? So some of best practice is to say, hey, make your query selector simple, all right, as much as possible. And if you need to use get element by ID, start them from the entry point or put it in from the starting container. So you can now from there work on those elements. And this is also what we did here with document.fragment as a way to create now our specific car to that, right? And actually dive deep into the weeds of this element, right? And how template now here it is this particular HTML element that instead of actually render this set of components instead of HTML tag, it will hold that in memory, so you can now with JavaScript call that around something, right? So this template, what it does is to now hold these elements in memory, do not render when the document is loaded, and then with JavaScript you can actually work on that. So at runtime you can now show those elements or do something with that. So this is pretty interesting, I must admit, absolutely. So then we look at this complex pattern that I mentioned before with the Observer API, what is the most common use case for, and then what we really care, which is the application state and network connectivity. I described what are the most recommendations when it comes to application state design, okay? And that is, understand what is the scale of the thing that you're going to store here, okay? At least initially, all right? And then define the structure of your data. If you need to access your data quickly, normalize it, which is part of the thing here. So minimize the cost access by normalize your data, and if you need to search for your data, so use index for that. And this is when the concept from database and is intertwined, and then also why we need to take a look at how the data is being handled at the backend side, all right, as a way to gain some much more perspective of what are the things that we need to do, which is a great stuff. And because this is the principle of the application state design. So minimize cost access, minimize access costs, minimize search costs if you need to, and then minimize RAM usage. So that's why once you determine what are the side of data that you want to load, as well as you improve the or you minimize the access cost by normalize your data structure previously that you defined that. So previously, scratch. So when you determine what is the scale of the data that you're going to store, and then the structure of those data, now to reduce the access cost, you normalize your data. And a good example of this is that, hey, you have now a particular way to eliminate redundancy and improve access time by saying, hey, if you can imagine, this is if you structure in your, this is if you have, similar to have a luggage. In your luggage, you have everything sorted. You have a structure here of where things gonna be there. So here is what I'm gonna put. Here's gonna put my shoes and the t-shirts and perhaps long sleeve. And this is my moccasins. And here I'm gonna put my laptop. And here my sockets, and here another stuff, and so on and so forth. So you get the idea, right? So that's something that you can. That's the applicability here that is needed, especially when we need to actually understand why we're doing the thing that we do, especially for front-end applications. Okay, and once you understand that, so once you know what is the scale of the data that you're gonna put here, okay, this is a good example here, the luggage. So once you know what is the amount of data that you're gonna put here, the amount of stuff that you're gonna put in your luggage, you need to know is define a structure to that, define the data structure here, and also is, well, some way to actually is reduce the access cost. So if you want to get a black sock, you know what to look at it. That's what we do here with normalization. And all right, and also we have is the what it is, yeah, and also we have is the, yeah, this is the normalization, all right, and also we have is the if you're going to improve, this is very specific to front-end applications. So if you want to implement some search operations, create some index, all right. So for example, and this is also good for your luggage. So if you need to search for stuff, create an index, create a bookmark, right? Put a bookmark in all of that kind of stuff, right? You need to find it. You know what it is. You know what it is. You don't need to actually think too much to do that. And if you, for some reason, offload data, okay, which is part of the interesting topic here, like this. If you need to, for example, offload data, which means that put some of your stuff in another place when it's needed, do that only when it's needed. I'm going to apply all of this concept here for my own luggage, bro. I'm definitely, perhaps my background right now doesn't illustrate that much because I'm starting to solve my own personal issues and all that kind of stuff, yada yada. but this is what it's gonna do, bro. Oh, yes. I like this move. I like this move. uh, so, uh, so if you need to offload data to some other places, do that when it's needed. All right, and if you do, so now pick the right storage to do that. Very, very interesting. Let's keep here with the luggage, and I want to describe this again to uh, to actually solidify, galvanize this concept, because this is something that you can apply even to your own life, right? So pretty much like have a luggage, where in there you say, hey, what is the amount of stuff that I want to put in here, right? Oh, that means is decide what is the scale of the data that you're gonna store here, all right, in your fronting applications. And then you say, all right, so how am I going to organize this data, right? So what is the data structure that I'm gonna use? Start from there once you know the scale of this. Interesting. 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 Okay. Man, I need to do this kind of real life exercise, real life example here, because now things plug in, things makes a lot of sense. It's for the aha moments. Okay, so we got this. So now that we structure our data, okay, then we would like to now is normalize this. What does it mean? Hey, if I want to improve the access time, I want to eliminate redundancy and have consistency in my data, which is, let me put all of the, oh my God, let me put all of this white t-shirt here, all of my black pants here, red sock here, my long sleeve, my long blue sleeve here, and so on and so forth. And all of this, it'll be, it'll make, oh my God. We do that is using normalization in the fronting application. And normalization is just several techniques that we apply to reduce redundancy and improve redundancy, improve consistency, and reduce access time. Holy moly! So, in the example of luggage, is, hey, we have, now that we know the way how we're going to structure our data, we need to normalize this as a way to have consistency and eliminate duplication here, right? That's interesting. So if you need to implement search operations, right? Use index for that. So now I'm going to talk in a more practical sense, in a more technical aspect here. When you define the scale of your, or know your scale and optimize accordingly. So know your scale and then define the data structure that you need to define the data structure that you need to. Hey, I need a hash. Hey, I need a collection. Hey, I need a binary tree or a link or a list, perhaps a heap, or perhaps a map and all that kind of stuff. So now things starting to make a lot of sense here. This particularly click is because I decide genuinely to understand where all of this data structure came from and what is the real applicability of them. What is the real life appliance here, you know? Oh my God, it makes a ton of sense. Good. So once you know the scale that you're gonna put in there, and also this data structure that you're gonna use that, All right. So if you want to now uh, improve access time, you normalize your data using this particular normalization techniques that are there are several normalization form. Right now in the front end we just apply only up to the second or third one, but the first one say is like, hey, all of the non-prime an entity must all of the an entity must have a one level. So an entity must have one level property, or an entity must have one level. Uh, entity must have atomic properties, which means is that we don't have is nested objects here, right? And the other is that, which is the second form, it say, hey, now each entity should have is, so each entity with their own primary key, non-primary key should depend on the primary key. Okay, must depend on the primary key, right? And the third form, which is quite subtle things here, it's a, hey, okay, this is when I need to put a practice more. This is what I need more practice here. This is what I need more practice here, especially to apply all of this relationship and all that kind of stuff. So atomic fields, right? This is the first normalization. All right, it's like, hey, data is atomic and it has a primary key, right? And when I say atomic is that, hey, you need to split that data to their own particular entities. The second form is say, hey, non-primary keys depend on entity primary key. And the second form is more strict, where it say, no, only, all right? So non-primary key only depends on entity primary key. So this is quite interesting. Why is that? Because this actually show my flaw in terms of data normalizations. Okay, and data normalizations. Okay, oh my God, data normalizations in data structures here. Data normalization and data structure. So what is the type of data that we're going to store here in this box, in this container, in this jar? Okay, Jesus. All right. So okay. Okay, I recognize my flaw here, and I know that I need to go with the practical aspect here. Practical, okay. Okay, I cannot skip this. I cannot skip this. And I must complete this in full. Okay, alright. Yeah, absolutely. Absolutely, bro. Oh my God. Holy moly. Anyway. Okay. All right. Absolutely. 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 Absolutely, bro. Absolutely. Jesus, French toast. Okay. 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 No. Anyway. Yeah, I cannot skip that. All right. And then we also look at how we can minimize search costs by actually implementing is an inverted index, like so, and that kind of stuff here. Very, very interesting here. Normalized states and how you can use an inverted index table to actually improve that. So minimize size usage, all right. And when it comes to actually deal with the network connectivity, which is the reason why we are going to build this Redis application, this Redis service, is as a way to understand now how the backing actually works, okay, and how they're going to send off data, and what are the mechanisms that is using behind the scenes. So as a way to just briefly explain how navigations happen in the browser when the user navigate to a particular URL, all right. So it went through this particular data. It went through all of this OSI model, which is the open system interconnection, right? So this is the way of how different computers with different hardwares and OS can exchange message, okay? And this is made of 7 layers. You have the application, which is the way of how now the user interact with applications and applications to the network service, okay? The presentation is that, hey, let's gonna make sure that this data actually is presented in a valid format, all right? And also, this is when encryption happens. Then you have season, when it say, hey, now it is time to manage which port we are going to use to send this information, and establish a connection. This is when connections and ports are being handled. Then you have the network layer, the transport layer, to know which protocol we're gonna use to actually send this data, all right? And that is which protocol we're gonna use to now establish this communication, this transport communication, whether it's TCP or UDP, connection based or connectionless. So TCP, so HTTP1 and HTTP2, as well as UDP, WebSocket actually relies on TCP, whereas the UDP relies on, or whereas WebRTC, Quick, and HTTP3 relies on UDP, is connectionless based. Then the internet protocol, the network protocol, to say, hey, what will be the physical path that this data is gonna move on, right? It's gonna pass through. So this is when they define the IP address, okay? Then you have the data layer, which say, hey, what will be the format in which this data is gonna be sent over. In this case, it get a particular message and is split into different frames. So now in this layer, it's actually describing is how will be the communication between end devices, not the client, the server, but a closed end device, okay, between two pairs of devices. And then you have now the physical layer, which is say, okay, now that I know all of these informations, I'm going to send that over the cable. So that has been sent, the ISP receives that, and now, because they might own their own DNS servers, or they can rely on third-party services that have this DNS service, which is act as a dictionary that store is, or that resolve the IP address with the URL, all right? It's sent back to the browser. The browser might store that IP address for next request, okay? And then is when the browser send the request to the server, right? So now that I know where it's going to send this data, this is when the TLS or the TCP connection happens. So first, it is made of ACK, sync, SYNAC. It is made of sync, SYNAC, ACT, which is this three-way of, which is this the model of passing three message to actually recognize if the other person is on the other side. In this case, the other server is on the other side. So the browser, the client send a sync message. The server responds that with a sync SYNAC, and then now the client say, okay, respond with the ACK, or send a request to the server with the ACK. So then is when the HTTP verb can happen: get, post, delete, blah 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 blah. You know, and this process, because it's quite slow, there is a reason why now there are other protocols like Quick that try to actually mitigate this, and not only that, in the TCP connections, because they were designed with no encryption, you also need to add this layer of this TLS layer, which is the transport layer secure, to actually indicate what will be the cipher that we're going to use. It can be synchronous asymmetric encryption. So for example, using is AAS, RSA, or Diffie-Hellman, which is using the public key encryptions, or it can be symmetric encryption, which is using now a key length of that, or it can be a hashing algorithm. So one of the subtle difference between a symmetric, and hashing algorithm is because, and I want to actually is as perplex as Claw here for that. Briefly describe. Oh, consist. They're adding that, bro. Oh, okay. They have to add that because they were bombarded, bro. Briefly describe the difference between asymmetric, symmetric, asymmetric. I think I wrote it. Asymmetric. Okay, asymmetric, symmetric, and hashing, right? And hashing. Encryptions. Encryptions. So symmetric encryption uses the same key for encryption and decryption, fast and efficient for large data sets. An example of this is ASS and DSS. Challenge secure key distribution. Asymmetric encryptions, it solves the key distribution problem because it uses different key, one of them for encryption and the other for decryption. Encryption is public and decryption is private, and as you can imagine here now, you have now a lock, right, that you can encrypt, that you can close that, but only whoever have the key can open up that and then access to your lock safe. Okay, this is asymmetric encryption because it generates a public and it generates a public and a private key. So the public is for encrypted and the private for decrypted. Okay, and usually that's stored on the server, most likely. All right. slower but more secure for key exchange. And then you have now RSA, ECC, interesting, RSA, Diffie-Hellman. And the other is hashing, which is one way to create a fixed length of any based on an output, right? Used for password storage and data integrity verification, so it cannot be reversed or decrypted. Example of SHA-256 and MD5. But this is quite interesting, and so what you recognize is this. So when we talk about asymmetric and symmetric encryptions, we talk about is if the key is the same or not. Okay? Symmetric encryption say, hey, this is the same key. It is fast for encryption and decryption, and it is also fast for large amount of data. And the algorithm is AES, okay, AES, and the other is CHA-20, all right, CHA-20, and then you have a symmetric encryption, which follow is the RSA, the asymmetric encryption, which is RSA, exactly, reverse Shamir Adelman, and this has proved to be very powerful. You also have the ECC, all right. What encryption? Elliptic curve, all right. Cryptography here, elliptic curve, blockchain elliptic curve. Is the asymmetric encryption algorithm that employs the algebraic architecture of elliptic curve with finite fields. Damn, son. A relatively easy to understand primer of elliptic curve. Oh my god. This was updated? No, 2013. The dawn of public key in cryptography. Whitfield, Diffman, and Martin Hellman. Shut up, man. A toy RSA algorithm. Not a perfect trapdoor. The author proved that breaking the system is equivalent to solving a mathematical problem that is thought to be difficult to solve. Factoring is a very well-known problem and has been studied since antiquity. See Sieve of Eratosthenes. Any breakout through the big news and will net discover a significant financial windfall. That say, factoring is not the hardest problem on a bit-for-bit basis. A specialized algorithm like quadratic sieve and the generalized numbers field sieve were created to tackle the problem of prime factorization and has been moderately successful. Okay. All this means that RSA is not an ideal system for future cryptography. In an ideal trapdoor function, the easy way and hard way get harder at the same rates. We need a public key system based on better trapdoors. Elliptic curve building blocks for a better trapdoor. So after introducing RSA and Diffie-Hellman, research explored other mathematic-based cryptography. Oh my god. Solutions looking for other algorithms beyond factoring that will serve as a good trapdoor function. In 1985, cryptography algorithms were proposed based on the esoteric branch of mathematical elliptic curve. esoteric math based on elliptic curve. But what exactly is an elliptic curve? How does the underlying trap function work? Unfortunately, unlike factory, something that we all have to do for the first time in middle school, most people aren't as familiar with the math around elliptic curve. The math isn't as simple, nor is explaining, but I'm going to give you to go over the next few sections. If your eyes start to glaze over, you can skip way down to the section. What does it mean at all? Stranger symmetry. Oh, the esoteric mathematic, bro. Oh. The esoteric mathematic, bro. The esoteric mathematic, bro. Here's a plot of the same curve with only the whole numbers point representing with a maximum of 97. This is all of the data points. Here's a plot of the same curve with only the whole number points represented with a maximum of 97. What does it mean? This elliptic curve discrete logarithm is a hard problem underpinning elliptic curve cryptography. Despite almost 3 decades of research, mathematicians still haven't found an algorithm to solve this problem that improves upon the naive approach. In other words, unlike with factoring, based on current standing mathematics that doesn't appear to be shortcut, this is narrowing the gap in trapdoor function based around this problem. To visualize how much harder it is to break, Lentra into the concept of global security, and then you have now, but this is following is this. So yeah, I don't want to dive deep in too much to this. Okay, elliptic curve cryptography. All right, but it's a cryptography technique that uses mathematical format to create key for encrypted and decrypted data. So that's huge. That's huge, man. Again, all of this is just algorithms, and this is one of the magic of encryption, right? That you can rely now on some hard work that other people have done, all right, to get an outcome, to get a value out of this. So here the RSC Diffie-Hellman, which is another one. There's another algorithm here, right? Just Diffie-Hellman. Okay. The Diffie-Hellman key exchange. Okay. But the point of this is that this set of algorithms that solves this particular problem is hey, let's gonna use the same key to encrypt, to encrypt and decrypt. This is symmetric encryption, and this is when you have now the AIS cha-cha-cha-20. Okay. This is symmetric encryption, DAS. Okay, so DAS cryptography. Come on, what French toast? DSS cryptography. All right, that encryption standard. Oh, interesting. That's what the name it is. Okay, that's interesting. Okay, DSS has been considered unsecure right from the start because of the feasibility of brute force attack. Such attack has been demonstrated in practice. See the EFDSS cracker and now are available on the market as a service. What? As 2008, the best analytic attack is linear cryptanalysis, which requires 243 no plain text as a complexity. Okay. Jesus. Anyway. Oh, so you have this one. This is, but this has been shown that it's secure for data encryption standard. Data encryption standard. Right? Standard. Okay. But again, given the same key, it's going to generate now it's going to generate a key. This is the algorithm that is going to generate a key, the same key to encrypt and decrypt. This has been shown to be vulnerable to brute force attack. Okay. But this is the subtle difference between the asymmetric encryption and symmetric encryption. Is that with the same key, you want is to encrypt or decrypt something, right? So you want to lock or unlock, right? So if you use the same key, you are using is a particular. This is known as symmetric encryption. You're using is the AES, all right, or the DSS, the data encryption standard. Both of them has shown that it's being secure, because if you perform some brute force attacks, you can actually figuring out that. Unlike the asymmetric encryption, which somehow we haven't figuring out any way to at least the elliptic curve cryptography, which is one of the esoteric. This is the esoteric branch of mathematics of the elliptic curve. In any case, the whole point of this is that this ECC, elliptic curve cryptography, or the RSA, what the RSA stands for? Encryption. Yep. River Samir Adelman. Okay. Rivers Shamir Adelman. Okay. So the Rivers Shamir Adelman, this algorithm, or the Diffie-Hellman or ECC, the elliptic curve cryptography, both of them rely on this key, right? But you have now this key, these two keys, one for lock and the other for unlock. All right. One of them is for encrypt, your public key, and the other for decrypt, your private key. All right. And then you have the hashing algorithm. But in any case, once you set up that, the idea here is to understand this particular algorithms, encryption algorithms, to then move on to how can we now establish a connection with the server, whether it's using long polling or server events or WebSocket, and what are the subtlety between them, you know? So for example, if you're using long polling, this is great. For example, if your application is for desktop application, the trade-off is energy consumption, because at every X amount of time you actually is now sending this particular at any X amount of time you are sending this particular data to the server, which of course drain the battery if you are in a mobile application. And the other is latency that is generated, especially if you now design your applications to target desktop and mobile, and then then the user now is moving from one antenna to another, right? Perhaps that user is on the road, all right? So now you need is to reconnect and you need to handle is the reconnection problem here. You know, that's what happened. And implementing this reconnection problem is something that is not quite trivial. However, this is one of the pros and cons of that. When you would like to use this long polling, especially for targeting desktop applications. So you want to avoid this for mobile applications. The other is server events. So instead of us setting up the connection from the client, all right, it's not the server that is established that connection. It is persistent because this is a HTTP technology. It's a server technology that now in the HTTP 2 it can handle more streams of data, unlike the HTTP 1.1. all right. So the benefit of this is, hey, we can now send data to the client without having to worry about the reconnection phase because it's automatically handled for us. It can reuse existing TCP connection with the server or TCP socket to say, hey, I have a pool of this, let me reuse some of these connections. The only trade-off is that it only supports data, it only supports streams of data, and it's a server-side communication. When you want to use that? Well, for desktop or mobile applications, where you need to implement some push notifications, so for example, it's also an alternative to the WebSocket when some minor latency is acceptable. Okay, and when you want to stream large, when you want to send large streams of data, so streaming large for large text data streaming is useful. So when to avoid that, for application, simple desktop applications, you will be fine with long polling. So the other is WebSocket, and how this WebSocket now introduces several concepts here that we might be quite familiar with or not. Okay, exactly. We might be quite familiar or not, but this WebSocket, because at the end of the day, it provides us an alternative to have these real-time communications, all right, by first using the HTTP 1 methods by sending a message with the upgrade to say, hey, can we upgrade that? Is the server now support this WebSocket? And if it is, it's going to upgrade the connection to that, to actually now have this client push and server push connection. But this is being handled, this handshake is being handled by the HTTP upgrade headers, right? And the reason why actually going to write this HTTP server, this Redis server, right? So here we talk about is the WebSocket API, right? And how now the WebSocket API, which is stable across browsers, it has a good browser support. It doesn't support is this back pressure. This back pressure is the amount of, so it's when someone actually talking to you so fast, right, that you can barely understand. You're like, wait, hey, I'm losing some data here. I'm not getting it, right? It's like, so back pressure is this in the context of computer science, so back pressure, okay? So is there resistance to the flow or fluid or gas through a system? It's like, hey, no, you are passing me through. It's also the resistance that I'm showing to you, right? So is the resistance to the flow of a fluids or gas through a system, right? And this resistance is because I don't have the capacity to handle this. So please chill, bear with me, and so on and so forth. back pressure in a stream. But again, this back pressure is the resistance to the flow of fluids, gas, or data, in our case, through a system. So if you're talking too fast, especially when you want to explain something, and that is something that I'm not get used to that, and you do that in like in a machine gun, like you're firing, so you're firing all of your idea like an AR-15, right? Wait, what the fuck? Can you buy this? Oh, this is replica. All right. Wait. Oh, this is airsoft. Oh my god, airsoft. Okay. Oh crap. Well. Well, that's the free market, right? But luckily for us, this is all airsoft. But again, this is not the free market. You know, what in the F? Can you buy this? This is free market, bro. Oh my god. We also should know is how to handle a weapon. Definitely. We also know how to handle a weapon. We also know how to handle a weapon. All of these are from airsoft. Exactly. Airsoft. That's quite interesting. That's very, very interesting. Anyway, but again, so if you or if I am fighting if I am fighting at you like an RX-16, but worse and all of these ideas simultaneously, as fast as I can, okay, as fast as I can, so you wouldn't be able to actually understand what I do. Say, hey, no, slow down. There is a resistance here. So that's back pressure. Interesting. So back pressure is the resistance. Of a flow. Okay. Is the resistance? No. Is the resistance to the flow? Is the resistance to the flow of gas? Is the resistance of the flow of fluid, gas, or data through a system? Through a system, right? Because WebSocket doesn't support that, so now we have is the WebSocket stream, right? How do you call back pressure in Spanish? How do you call back pressure in Spanish here? Contrapresión. Okay. Contrapresión. Presión posterior, presión trasera. Resistencia. Okay. Back pressure. Resistencia. Contrapresión. Contrapresión sounds more accurate. Yeah, contrapresión sounds very, very more accurate. But in any case, yeah, data encryption standards here, and that kind of stuff. So yeah, now WebSocket stream interface is say, hey, it is a promise-based alternative. It means that it is time dependent. All right, when you talk about promise, it's like, hey, we don't worry about when this will be resolved. We only care that by the time that is done, we get our data, and also because it's using now a streamed API, it can handle automatically back pressure, right? This resistance of that. How does it handle that? It is quite interesting. uh, but the Stream API can handle that back pressure from the browser. This feature is available in web workers. Allow JavaScript to programmatically access the streams of data received over the network and process them as desired by developers. So I can receive streams of data over the network and process them as desired. Oh, this is quite interesting, bro. And processing as desired. Okay, so that's great. That's awesome. Additionally, we have now the Web Transport API, which is a lower level that it works now on because this use HTTP 3. The Web Transport it now uses HTTP 3. It's now it is UDP. Interesting. All right. So now it comes from all of the benefits of the WebSockets, but without the latency. It enables reliable transport via streams and unreliable transport via UDP like datagrams. These include head-of-line blocking, faster performance, better network transitions, unreliable transport. Anyway, that was quite interesting, right? Very interesting. And this is why we are here, why we are now looking at the why we are looking right now at the catalog here. Let's get into this. All right, resume building here. Okay. So, because on the previous section, what we did is just to elaborate a little bit more of the introduction, repository, and by a pour. So we actually cloned that repo here and say, hey, you know what? Give me a second here. Two-zone, variety, feature large, index, enterprise UI development testing. No. There you got it here. And I want you to follow me along here with this. Here. There you got it. And this is quite interesting because here in the main, the only thing that we're doing is now accessing to the net. All right. So, as you can imagine, we are actually accessing is to a Node.js instance. In this case, it's actually accessing through a bond, which is another JavaScript environment. That is, oh my God, here we got bond, the bond runtime. You know, wrapper around a wrapper around a wrapper. Jesus. Oh, okay. On August 24, 2022, Oven, the company behind Bond, announced it has raised $7 million in funding. The round was led by Kleiner Perkins. Okay. Kleiner Perkins. Oh. With the participation of Guillermo Ranch. Jesus. That's quite interesting. G combinators and others. Since Bond 1.1, the runtime support Windows 10 and later along Linux and macOS, It also introduces a cross-platform bound shell for running some bash command. The word bash is to me interesting because I bash, and I don't mean that. Bash in Urban Dictionary. To master, to verbally attack. Okay, jerking off. Okay, verbally attack. Bash in Spanish is an attend. Oh, it's like an attend. It's like a bash. I'm gonna bash you. Oh, I'm gonna hate you. But it's an attend. You're bashing. Interesting. Bash. It's an attempt to try. Okay. It's implementing in a bash, an attempt to. Command without extra dependencies. Alright. So the runtime support foreign functions interface. But, oh my god. It supports bundling, minifying, server-side rendering, Svelte, Nox, and Vite. Bundling also refers to the process of combining multiple files and assets like JavaScript, CSS, and HTML into a single file or a small number of files to reduce the number of server requests to enhance performance. But it was designed by Jaron Sommer as a drop-in replacement on Node.js. Bond used WebKit JavaScript core as the JavaScript engine. And unlike Node.js and Dino, which both use the V8 engine. Oh, you are using is the JavaScript core. Okay, you're using is the Alright. JavaScript core. Okay, and web core is a layout rendering the document object model. Library for HTML and scalable vectors. Okay, that's quite interesting. All right. So because we're using this bond here, right? This runtime that use now the WebKit or that use WebKit JavaScript core. Okay. An optimized just-in-time compiler use LLVM to generate optimized machine code instead of using now the V8 engine. Okay. WebKit, the original author is Apple, right? Exactly. It defined this WebKit similar for the Apple Inc., Adobe Assistant, Sony, KDA, and Igalia. Holy moly. It is written in C++, and that makes a lot of sense. So this bond it will act as a replacement of Node.js, which is a JavaScript runtime package manager, test runner, and bundler built from scratch using C programming. Here we go, bro. It's an imperative, general purpose, statically typed, compiled system programming language. It's an intent of designed by Andrew Kelly. It is intended as a successor of the language C. This was launched 8 years ago. Holy moly. Memory handling. Based on malloc, which is allocate memory. Memory allocate. Exactly. Malloc set aside a block of memory for use in the code and returns a reference to the memory as a pointer. and there is no mechanism for correct. Oh, there is no mechanism to ensure that the memory is released. You allocate, but you don't deallocate that. Okay. A common solution to this problem is the garbage collector, which examines the program for pointers to previously allocated memory and removing any block that no longer has anything point to them. SIG aims to provide performance similar to a better than C. Option types. Jesus. Okay. Anyway, since bond, you got this. So here we're using bond. All right. This is a wrapper around a wrapper around a wrapper around a wrapper. So we're using is not bomb. This JavaScript runtime, because it's a JavaScript runtime package manager test runner. Holy moly! It's a JavaScript runtime test. It's a JavaScript runtime test runner package manager and bundler built from a very right now obscure programming language called C. That behind the scene, instead of using the V8 engine like Node and Deno, it uses now WebKit for that. I don't want to dive deep too much into the weeds for this, okay? With that, that'll be all for me. It's enough. It's enough for me to understand this, because there is a lot of shit going on, bro. There's a lot of things going on. There's a lot of things going on. There's a lot of things going on. Bond. It's like bond. A JavaScript runtime. Right? Oh my god. Okay. This is the platform. I'm gonna call this. This is the platform that we are going to use. All right. So this is the platform that we're gonna use to run our JavaScript code that is a JavaScript runtime test runner and bundler written in an esoteric, because this right now is like an esoteric programming language called SIG. Jesus. Man, you got a lot of free time in your life. You should have you should have a family, man. I don't know. You should have some. Jesus, what the? You should have a family. You should have a hooker story in your life. Someone that you really love, but you love. So you give up your heart to a hooker, and now she of course doesn't pay you attention, because despite you have a lot of money, you don't have the attitude and the skills, and you're not a person attractive. You're not an attractive person, and yeah, that's Jesus. All right, man. All right, you need a heartbreak story in your life. Anyway. Jesus. Oh my God. Anyway. Again, I say that, but if we have a serious conversation here, We're talking about now competitive advantage, and we're talking about now power. We're talking about here is this high value people, you know. All right. So this is Bond, right? And we're gonna run our code in Bond, just like that. So it is, right? Yeah. So response to a pin, right? So we have now read the instruction here. In this stage, you will implement your own solution. Like stage 1, your repository doesn't contain comment code. Okay, your repository doesn't contain commented code to pass this state. 98% of users who attend to this stage complete it, and it is your task card below contain a description of what you need to implement to pass the test. Mark this step as a complete when you read the instruction here. So your task. Okay, in this stage you will implement support for the pin command. All right. Redis client communicate with Redis server sending commands. Okay. Redis client communicate with Redis servers by sending commands. Okay. Being in Redis and command. Interesting. Respond to pin. So respond to pin. Right? Okay. So because of this, right? Redis client communicate with Redis servers by sending commands. Okay, we're gonna implement a pin. Okay, we're gonna implement is a pin. So Redis clients. Okay, so Redis clients communicate with, and this is the architecture, Redis server. Okay. by sending commands, right? So Redis client communicate with Redis server by sending commands, unlike HTTP server and HTTP client and server, or this browser in client and server, HTTP server, where they use now HTTP, oh Jesus, HTTP. Okay, here the using is now commands here. No, right. Okay. Holy mother. Okay, so this is the way how they communicate that. All right. Okay. Yeah, you know what? Good. So far, so good. Commands. So for each command, a Redis server sends a response back to the client. Okay. So for each command, Redis server sends a command for each command. Okay. For each command, a Redis server sends a response back to the client. Commands and response are both encoded using Redis protocol, and we'll learn more about this in later stage. Ping is one of the simple Redis commands, and it is used to check whether a Redis server is healthy. So the response for the ping command is pon. This is the string pon encoded using the Redis protocol. In this stage, we'll cut corner by ignoring client inputs and hard coding pon as a response. We'll learn to parse client input in later stage. Okay, but for each Redis server sent, okay, for each command, Redis server sends a response back to the Redis client, right? And commands are and commands are response. Commands and response are both encoded using Redis protocol. So commands and response are both encoded using the Redis protocol. Interesting. Are encoding using this particular protocol. Oh crap. Command and response are both encoded using Redis protocol. Let me put it here, similar for this. For each command, Redis Server sends a response back to the Redis client. Okay. So in this test, the tester will execute your program like this. Your program shell, and it sends pin command to your server and expect this. Your server should respond to this with POM encoding REST simple string. No, you can ignore the data that the tester sent you to this stage. We'll pass the client inputs and also all of that. So if you go to examples, so here I'm going to create now. I'm going to create a server to handle this connection from the net.socket. Okay. Interesting. But this is just like a server, right? But in our case, we want to now receive that. So in our example here, we say, hey, now that we create our server to handle the connection here, because this is now a socket connection, why it doesn't complete that? Net.socket is unresolved. Okay. Do I need to install this? Well, in theory, I shouldn't install anything. I didn't have any package here. Perhaps the dev dependency? Yes. I need to install that. Okay. Let's get into this. npm install. Right, the dev dependency. There you got it. Alright. So now we can have this nice little auto-completion. Good. Okay, so we got the connection because this is a socket, right? It extends from that, and a socket here that extends from string duplex. Interesting, is implementing this readable and writable interface, right? So this client is an abstraction of the TCP socket or an streaming ICP endpoint. Usename pipes on Windows and Unix domain socket otherwise. It is also an event emitter. But this net socket can be created by the user and used directly to interact with a server. That's exactly what I'm doing here. And now creating is this, and I want to interact with a server. So the user can use it to talk to the server. So by the time now I implement this, all right, and I listen for a pin on data connection on, because this is an event listener, it also is part of the event listener. This is an abstraction of the TCP sockets. This connection here. It's also what is the TCP socket, bro? Can you elaborate this more about this? English, please. that serve as an endpoint for sending and receiving data. Okay, this socket is an endpoint for sending and receiving data. For sending and receiving data. The term also socket is also, but it's that, it acts as an endpoint. So this is the endpoint, right? So when we talk about socket, this is the endpoint for sending and receiving data. Okay. So this is an abstraction of these endpoints for sending and receiving data that we can now describe or use to interact with this. So hey, I'm going to use these sockets, and that is going to provide me now this set of events for that. It can also be created by Node.js and passed to the user when a connection is received. For example, it is passed to the listener and it's using its node. That's great. It is passed to a listener as a connection event emitter on a link server, so the users can use it to interact with the client. This is interesting because now this is using the observer design pattern, right? So let's dive deep into this, bro. Let's freaking dive deep into this, bro. You know? Wait, what? And why not? Events. So much of the Node.js core API is built around the automatic, asynchronous, event-driven architecture. The way of how we build this events, which is a certain kind of object called emitters. Emit named events that cause functions object listeners to be called. So this is something interesting because this is follow this event. So you can say claw here. So events in Node.js. All right, it is safe to assume that events in Node.js are part. It is safe to assume that events in Node.js are an abstraction of the observer pattern. In other words, and behavior. In other words, a design pattern behavior. That makes a lot of sense. Yes, not okay. On the observer pattern, and this observer pattern, which come from this creational pattern, this particular pattern that, which is recurring stuff that happens over and over and over, and then we define some sort of way to tackle it. All right, the design pattern. At the end of the day, they are typical problems, typical solution to common problems. All right. So, because this is now implementing that, similar to promise, okay? We can think of promise like this. So now it makes sense to say, hey, because now this is a connection, and this is a wrapper of the socket, this, which is an abstraction of this endpoint, okay? This abstraction of the endpoint here, which now uses the observer design pattern, which now we don't worry about when this data will arrive. We only care that by the time that this data is, we can subscribe to a particular event, okay, and then act accordingly, run a function. So in this case, it's data, okay, and followed by the listener, which is using now, instead of a function, is using an arrow function. Okay, so by the time we have that, we're gonna receive is the data here, and the data, it is like, what is the data here? You know, what is the shape of this data? I would like to know. Oh, it's a buffer. What is a buffer? Ah, here we go. Here we go. Yeah, what is a buffer? Take me to that, please. Will you? Okay, so what is a buffer? Alright, interface buffer extends from the unsigned 8 array. Makes a lot of sense. Alright, so write strings of buff and offsets according to the character in no, according to the character encoding here. So this buffer that extends from this writes a string to a buffer. Okay. A buffer, how can we describe buffer in Spanish? So buffer in Spanish. Okay, some sort of. Okay, so middle memory, buffer, amortiguador, memoria intermedia, un amortiguador, un tapón. Oh, right, okay. And in this case, it's a temporal memory. Okay. So a buffer is a memory, it's temporal memory. There's a lot of things with buffer. Okay, buffer. So it's a region of memory used to store data temporarily while it's being moved from one place to another. So this buffer that we're going to receive as the data, to put this data here momentaneously while we put it into another place. All right. What? Object with listener to the data event. This event is triggered whenever the servers receive data from the client. Exactly. So when the data is received, the callback function is executed inside the function, and two things happen. The received data is converted to a string because data, what happened is that is a buffer. Okay, so this buffer is a temporarily place. We're going to put our data here, and it's extent of the unsigned integer. The unsigned integer. What is this? The unsigned integer here, you can see here, is the unsigned integer 8 array. It means that you can represent collections of arrays. It's an I bit, relatively indexable. What the fuck is this? Takes an integer value and returns an item at that index. Oh, but this comes from the global, from nodes. Relative region array like .at, and region disposable. But again, this unsigned here, okay, which is a representation of an 8 signed bit, which means is a bit, okay, a bit representation, where the question is that I would like to okay, this 8-bit representation is part of the data structure here as an array like. So this 8-bit representation, what represent? So each one of those slots can represent is 8-bit. If we talk about 8-bit, what does it mean? In English, please. All right, 8-bit unsigned content. How many this can represent? 8 bits unsigned. If I say 8 bits, yeah, what does it mean? Exactly. Oh, okay. You can represent it as a byte. Okay, from 0 or a byte. Oh, okay. Oh, okay. So you can represent here is a byte. But here, technically speaking, you can represent now a 8-bit in each one of those positions of this array, all right? That you can put numbers from 0 to 250. So for example, if you wanted to create that, here when you say, hey, node, I want to get in here and say, hey, let's go to define now accounts here called, or preferably array that I want to is after that mutate their inner values and that's an array because I want to mutate the inner values, not the reference. So I'm gonna put this array here and give me now a collection of, let's say, 6 ones, right? No, 6 slots here. It say, hey, requires, okay, all right, because it's a function constructor. You gotta be freaking kidding me. There you got it, right? So if I want to take a look at the console log of the array 1, I can take a look at that, right? It's all of zeros. But what I can say is, hey, this array at this position, let's say position 2, okay, I want to now represent that with 243, right? Right, and then I console the log. Now that's exactly what it's doing. It's like, hey, you now going to, you put this number here as a representation, but at the end of the day, the buffer which extends from these collections of this, in this case, unsigned 8 array, right? This is a temporal memory for us, right? This is a temporal memory for us, where you can write here data, or you can read. It also transforms to a string, all right, to JSON, all right. It's like, hey, I want to transform this data that I receive, like zeros and all of these zeros and bits, and all of these bit representations, and then I want to, have access to that. You can also have the slides and all of these methods here. You can subarrays, write big int 64, write big int, unit, and all that kind of stuff. That's quite interesting. Okay, but again, we can have now access to this data, all right, with the buffer, right? But by the time we get that data, all right, which is a buffer, which is now this class, right? That if we want to, for example, this, which is a buffer that allocate memory for us, and if you wanted to not only, you wanted to check that data, okay, the French fucking up, there you go. If you're gonna now attach some data to that, so want to see that data, my question is, well, I just want to print that out. You're gonna print log. You're gonna console log that data that I received, right? Because if I do this, this data is now a buffer which extends from this. I just want to print. You want to console log this data, just like that, just for demo purpose, right? And say, hey, the connection right here for that. So I just want is to do this. There you go. Just one is to now exit from this. Yes, please. And I want to is run this. Right? You say npm run def. Okay. And why not? I'm actually here. Oh, the way you need to run this is by so your tester will execute your program like this. It'll send the ping command to your server and expect pound response. But I don't want to do that. In fact, well, actually, your program. Oh, because you say this one. Because it's running this bash, it say now, of course there was an error here. Your program line 15, exit bound not found. How can I run this? npm run def bound command not found. Exactly, but you don't install that command. So you say, hey, I received this data, right? So I received this data. And I received this data, and then I'm going to now send a command or a response to the Redis servers using the connection right in, okay, right here with the buffer, this temporary memory here, on this. So by the time we run this, okay, the tester will execute your program like this. It'll then send a ping command for that. streaming build logs. Step 1 complete. Step 2 complete. Step 5. Oh, to install Bond. But here we didn't install Bond locally. Okay, they bundled that. Run and test on your code. They build Bond, and then you got access. But as you can see here, look at this. This is exactly the data that we are receiving here, and I want to actually show this to describe that this is the data that we are receiving from that. This pin, okay, in this particular format, in this buffer, that's going to put it temporarily there for that. So our task, right? So the task here is that. Okay. It's now the task here. Is this one. Ping is one of the simple Redis command. Okay, task. This one. Response to a pin. And here is the output. But this is just a way to understand that. All right. The point of exactly despite that this can be duplicated is just to show that to show how this server receives the data from the socket, okay, as a buffer, a memory, a temporary memory as a unsigned 8 array. This is by default. So that'll be all for this video. Take care. Bye bye.